Hello, everyone. How are you all doing? Good. Nice. Cool. Just for me to gauge the audience, how many of you develop APIs, like write APIs on a day-to-day basis? Cool. Yeah, quite a number. Nice. And how many of you consume APIs, like external, internal? Nice. Awesome. Cool. Yeah, through this talk, my goal is that you would be excited about APIs, you would be excited about using them, and you might be intrigued about the number of tools that are available that makes your life easy around APIs. Feel free to interrupt me at any time. I'm very happy to answer questions. How to securely expose API data to end users? A little bit about me. I grew up in Mumbai in India. I did my undergraduation and my foundation for education for computer science, math and science was there. I also had a chance to work there for a couple of years, which was really nice because when I came to the US, I could bring in my experiences of the culture, which is very different because the people out there are more religious and spiritual as opposed to being more logical, maybe in the West. So I think I assimilated both of the cultures pretty well when I came to the US. I experienced American education for the first time in Carnegie Mellon in Pittsburgh. And I felt the cold for the first time as well. And my excitement for the snow lasted for just 1 week. I moved to sunny California in 2006 and I've been here. I love the perfect weather, the beautiful diversity of people, as well as food. A little bit about my interest. I love building web applications and UI framework. In nutshell, building quality products around web applications. Everything right from the time the user comes into the website to engage the user and give them something that keeps them coming back and again. That's my interest. Moving to management, I really love connecting to people. I love mentoring and onboarding. I find out as to what is it that really motivates every person and what is it that takes for them to take to the next level. And my fun interest. I love camping, swimming, snorkeling, and a lot of travel. I do that a lot, but can never get enough of that, right? Cool. APIs. It's an acronym for Application Programming Interface. They're functionalities that are exposed over the web, or we could have internal APIs, which is within the organization used between products or between systems. Take, for example, Google Maps. Google Maps started off as an application, but eventually they decided to build it as a platform and expose it as an API. I'm pretty sure the time that they did that, they had little idea on the number of applications that could be built on the top of it. Like for example, today on my phone, I have an application that tells me where exactly I went for breakfast, where did I go for lunch, what is the route that I took to come to work today, how many miles did I walk, how many calories did I burn, and so on. All of these applications are built on the top of Google Maps by the power of APIs. So APIs are really powerful and they're super cool to use. Let's talk a little bit about their design. So APIs are generally designed by product managers, by engineers, and by marketing people coming together. So between the three of these groups, together they have to have a design sense. As in, they have to make the APIs such that they are simple to use. They're pragmatic, very intuitive. Like when you look at the API, you should have a good idea as to what is it that this API produces. What is it that it consumes? What is the real intention behind it? Everything should be very easy to infer just by looking at it. Here is a very good example of a very bad design. So we look at these doors with really big handles, and there are labels that says push. Now, looking at the handles, when somebody holds on to that, the intuitive thing is to pull. No one's going to read the label that says push, right? So this is clearly a bad design. The same principle can be extended to APIs as well. We should keep it simple and not really make it overcomplicated by putting in verbs in them, by making it, by overloading it. Like for example, at Ticketfly, we have an API to get the upcoming events. So we call it api.ticketfly.com/events.json. So looking at it, you clearly know that this is the one that's going to give you the list of events. And the response format is JSON because everything is in the API itself. Bottom line, keep it simple. Burning Man. How many of you have heard about Burning Man? Awesome. How many of you have been to one? Oh, cool. Nice. Very nice. I haven't been actually. I want to, maybe next year. So Burning Man, briefly for people who don't know about it, it's a very interesting event. Of course, you should talk to people who have been to one. But basically what they do is they build a city in the middle of Nevada. It's like in the middle of a desert, middle of nowhere. And we have all these people coming in and they pretty much inhabit the place for 1 week. And they do whatever comes to their mind. So some people do art stuff, some people do music, and there is no clear rule as to what is it that can be done. But people just go there, camp out, take their RVs, have fun, and come back. And we are talking about close to 65,000 people, so it's a big number. And for Ticketfly, when we signed the Burning Man deal, it was a big deal because they are one of our most high-profile clients. And selling tickets for Burning Man, it's a privilege. We in fact broke the record and we sold about 38,000 tickets in less than 44 minutes. That was a very big deal, and no other ticketing company has done that so far, so that made headlines, which was really cool. So now the challenge that we faced was the contract was signed, and Burning Man now discourages third-party entities like StubHub, eBay. They don't want people to buy tickets from the Burning Man site and go to one of these secondary sites to resell them. They wanted to keep all the business in-house. They wanted to keep it within their system. And Ticketfly now had to support it. From Ticketfly's perspective, we only deal with primary ticketing. We had never done secondary ticketing before. So this was a brand new system that we had to build and integrate with Burning Man. So Burning Man, how do they discourage third-party entities? They do this in the following two manners. OMG sale. They have an OMG sale where they set aside 1,000 tickets. These tickets that are again sold through the Burning Man site are sold solely with the purpose of resale. So all the names on these tickets are totally transferable. It's absolutely legal. And the second is the STEP program. STEP stands for Secure Ticket Exchanging Program. It's secure, so there is no room for scalping or any kind of bot activity around here. So you come through STEP program, you know that through this manner, you could securely exchange the tickets. So if you haven't got a chance to get the ticket through the primary ticketing, through the Burning Man website when they opened up, this is a place for you to get tickets through those people who do not want to use the ticket for some other reason. So it's a way you can exchange tickets. So Burning Man wanted to do this. And this is the specification that Ticketfly was handed. We had to integrate with the STEP program, and we had to maintain a waiting list and a sellback list. Waiting list is the list of people who are waiting in line to buy tickets because they couldn't get it from the primary ticketing in the first place. Sellback list is again the list of people who want to sell the tickets back to Burning Man, that is back to people who might be waiting in line. And this again, we have a bunch of rules around it, as in how many tickets can you buy, how many tickets can you sell, and then even when you get a chance to buy the ticket, it's only, Burning Man gives you 72 hours. So if you don't respond within 72 hours, it goes to the next person. It's like a first come, first serve basis. So all of these rules being integrated, we had to integrate with the STEP program within Burning Man. So we knew that we had to design APIs and integrate with them. They had a JavaScript model and they would invoke our APIs. So API design is pretty straightforward. We use the REST architecture pattern, followed the HTTP protocol, the industry practices, the best practices, resource-oriented, our APIs were ready, which is good. So now, when we decide to expose to the public, it becomes a bigger challenge. What happens now? We are curious to find out who really is using this API. It was designed for Burning Man, so we want to make sure that it is only Burning Man and no one else uses these APIs. So we had to pretty much lock down this usage to one client. We had to ensure that. Then how about the users themselves? They have to be authenticated. It has to be a secure connection. And we also want to collect more data about this usage. Who is really using this data? How much are they consuming? What is the location where these IPs originate from? And so on, right? You want to collect a whole lot of metrics. And then in the contract that we signed with Burning Man, there's a clause that says how many requests per minute can be hit by one user per month, or per year, or per API. So all of these terms are clearly specified in the contract, which is good. But we have to have some way to monitor this usage. So we needed also a way to throttle the usage as and when this contract was broken. Basically more visibility. So keeping all this in mind, we put together these set of requirements. Security. We want to make sure that the talk between our APIs and the client is secure. Tracking. We want to collect a lot of metrics, so we should have some kind of tracking mechanism. Throttling. We want to make sure the usage has a potential to be throttled if any contractual term is broken. We want to ensure loose coupling. Now what does this mean? We have a set of internal APIs and we have the APIs that we expose to the client. The dependency between these two sets should be minimal. So that for some reason, if our APIs have to evolve over time, if we need to change the signature, if we need to change the response, the impact over the client is minimal. I mean, we can always ask them to retest, but then we shouldn't really break their usage, right? Scalability. Now we anticipate a certain number of users to hit our APIs. And we of course have throttling in place. That being said, you really want to reach the maximum number of users over time. So your applications behind these APIs have to be designed such that they are scalable. Let's talk about each of them in a little more detail. Security. We want to ensure that the URL is secure. That is, when it is exposed to the client, it is HTTPS. So no one can really sniff the network. There is authentication in place. So the users who hit our APIs are authenticated. So we can ensure that it's only the right users who have access to the APIs are actually hitting the API and no one else. Tracking usage. We want to measure so we can improve. Now the things that we would like to measure, like in the graph that I've pasted, we use one of the tools to get the number of users, the request, error rate, response time. There's a whole lot of metrics that we are interested in, so it's important that we have some kind of tracking mechanism in place. We want to have the ability to troubleshoot. You want to know what are the different kind of errors that the users face. So if there is any corrective action that we need to take at our end, we are able to do that. We should have the right data so we can make better informed decisions. Like if you see at this chart, you can also see where exactly these APIs are actually being hit as to what is the location that is originating from. This is just one example. There are plenty of tools, but then it's important that you have some kind of visibility. Now, a company like Ticketfly, we have lots of data, right? You don't want to expose all of this data to the client for two main reasons. One, no client would actually be interested or would really have the patience to look at records of data more than 100. Maybe 100 could be, it's an industry standard that people accept as an okay amount of data. More than that is practically useless. At the same time, on the server side, you don't really want to run a query that's going to return millions of records of data. That's really going to stress your server out. So for these two reasons, you need some kind of mechanism to protect your servers from this risk. Throttling. So when we signed the contract with Burning Man, we clearly had contractual terms which specified how many requests can be hit per user, how many requests can be hit per month, and how many requests can every API serve. Pagination. We have to control unbounded queries. So if there is a buggy client or just a client with less knowledge who is sending in a query which is unbounded, assume something, assume some limit on the server side so we don't really issue a query that's going to return millions of records of data. We actually ran into this problem at Ticketfly. This was quite some time back when we were just starting out and the amount of data we had was big, but it wasn't big enough. So our events.json actually returned about thousands of records, which wasn't too bad. And then we had certain fields to restrict it. As in, if you want to search by artist name, by location, by price, you could specify, and then it would return reasonable amount of data, which was all good. And the response time was reasonable enough. It was in milliseconds. After a while, obviously this data grew, and we had some clients hitting our APIs, returning a whole bunch of data, and the response time climbed up to some seconds. So this is when we introspected and we found that we were actually issuing unbounded queries, which is pretty bad. So now we have tightened that, and we make sure that all our APIs conform to that. So the idea in summary is that assume some defaults. Don't return millions of records of data from the server. And also expose an attribute in the API itself. Like in our case, it would be something like api.ticketfly.com/events.json ? Fields equals something, whatever the client needs. So whatever attributes the client specifies, just return those records of data. Like in the event object that I'm talking about, that has like hundreds of attributes. Not any client would require all of these attributes. They might be interested in 5 or 6 or at the most 10 attributes. So getting just that amount of data from the server to the client is sufficient. Loose coupling. Like I said before, we have a set of internal APIs that our developers maintain. And we have these APIs that you expose to the client. The dependency between these two should be minimal. You want to have loose coupling so that we can evolve our APIs over time with minimal impact to the client. This can be done in multiple ways. One is versioning. Like in our case, we use simple ordinal numbers. Like our API actually goes by api.ticketfly.com/v1/events.json. So when you look at it, you know that this is version number 1. And when we develop and release the next version, we'll just increase the ordinal number. So when a client sees v2, they know something has changed, something different to expect. Scalability. We expose the APIs to public. We have to be prepared for the increasing number of users. At Ticketfly, we design our applications stateless. So we just deploy them on multiple servers, put them behind a load balancer, and our APIs are able to evolve. It's important that we think about this right at the design stage itself and not when our API really goes viral, which is what we want. Are there any questions so far? Yeah?
It's sort of a question. When you're talking about unbound queries, originally were you guys, like, I don't know if you're using like SQL or whatever, but were you returning every possible set of columns in that table as opposed to like the person limiting and picking the data they want to return?
Yes. The question is, what is unbounded query? Are we returning all the records, all the attributes of, like all the columns from a table? Yes, we were doing both actually. We were doing that, and we were getting all the rows from the table. So basically, so it's very stressful. So considering our table, we had like hundreds of columns. So we were returning all of that, plus we were returning millions of rows of data as well. So now we have restricted on both the terms. So we assume a max of 100, and we also return only 10 or at the most 15 attributes, which is what most users are interested in. Thanks. Cool. So Ticketfly API design. When we designed our APIs, we made sure that we followed the best practices. We followed versioning. So like I talked about the ordinal number, we made sure that it is upfront, it follows immediately the host name, so it catches people's attention. They know that it is important and it gets its due importance. Error handling. We spent a lot of time thinking about the potential errors that our API could hit, and we tried to design it around it. We followed the HTTP protocol, so all the standard error handling, error codes are the same that we followed. Like for example, if a user is unauthorized, that is, if they don't send in the right OAuth token or the API key, we return a 401. So everyone knows that 401 is unauthorized because HTTP standard protocol says that, and it's good if we follow the same standard. And if there is any missing parameter, then we send in 400, which is bad request. Similarly, if it's malformed, we send in a 404, and so on. We followed industry standards. All our APIs are resource-oriented. We follow the get, put, post, basically supporting all the CRUD operations and the standard HTTP protocol. So now our APIs are designed and they were ready to be exposed to public. But then the requirements that I mentioned before, they weren't really met. Security, throttling, rate limiting, getting collection of metrics. So all of these requirements could be dealt by building tools in-house. It could be done. Given the resources and time, we can do it over time. But in our case, the contract was already signed, and we didn't really have the time to do all of this, which is why we spent some time researching tools that are available in the market that we could use of. There were plenty of tools, Mastery, Apigee, Layer 7, and the specification, the requirements that we were looking for, like the ones around security, throttling, rate limiting, and actually even the cost, were pretty much comparable, and most of these tools provided them. For us, we leaned towards Apigee, mainly for the ease of setup. It was really easy, like we didn't have to contact the sales team to sign up for a trial. I could just download it on my computer and then build a quick prototype, and it was all up and running. So the setup was really easy. Plus the free account was really good. In fact, we're still using just the free account for a Burning Man client. But then, over time, if we decide to use more of these APIs, and we want to have all our APIs routed through Apigee, because you want some layer of abstraction, you want some kind of loose dependency for sure. So if we want to go that route, we probably have to do some more research, play with more tools, and see which one really goes our way. So why again did we use a service like Apigee? With Apigee, you can register your app as a developer with Ticketfly. And then once we authorize this developer, they get a secure OAuth token and an API key. It's only with this API key and the secure OAuth token can you access our APIs. So with Apigee, you get that security layer for free. It gives throttling of users. The management is through the Apigee console. And it's really straightforward. You could look at all the users, you could see their usage, you could upgrade them, downgrade them. So the web console is a big plus. It gives us API management. So the versioning, formatting, all of those things could be changed at the Apigee front itself. And you don't really have to change your internal APIs. It could actually be, a different format altogether, but then you could change it at the Apigee level in case the client wants that. Monitoring of data, tracking of the usage, the amount of metrics that Apigee provides is pretty incredible. And again, it provides a layer of abstraction, that loose coupling that we really want. does the solution look like? The first step is the yellow part, our APIs. So our APIs are designed at our front. So we follow the best practices, we made sure that we have the industry standards in place, our applications which the APIs hit are scalable, they're behind a load balancer, so all good on that front. Now comes Apigee. Each of the APIs we abstracted. We built like a facade pattern and built an API proxy. This is designed through Apigee console. I'll show a demo later, but then the idea is that we are building an abstraction layer over the API. So we are hiding the dependencies from the external client. Once these proxies are ready, you package them into products. So each of these API products could have multiple proxies. And once the products are built, Ticketfly is done with the Apigee part. Now, as a Burning Man developer, you register with this product and get yourself a secure app key. Once you get this API key, this is yours to keep. It's only with this API key can you hit our APIs. In fact, we go to the next level and lock down our APIs so that the only way to access our APIs is through the Apigee console. So unless we have a developer who has registered themselves with the API product that we expose through Apigee, they have no access to our APIs, which is really cool. This is a more concrete example. If you look at this, our API looks like api.ticketfly.com/user/ticket exchange. The proxy that we build on the top of it using Apigee is called waiting list. So the end user hits waiting list and he has no clue that the backend or at internally we call it /user/ticket exchange. So that's why we abstract and hide the dependencies. So tomorrow if you're going to change that, the end user is not really impacted so long as you keep calling your proxy as waiting list. And once these proxies are built, we package them in a product called as Ticketfly BM API. And that's it. We are done with the Apigee front from Ticketfly. Now as a Burning Man developer, you register yourself with this product, and once Ticketfly approves this, we get a secure API key. And it's only with this API key can the Burning Man developer access our APIs. So looking at the usage, when we look at the metric, we can easily find out as to who is this user who is accessing it. And what does his usage look like? Apigee provides numerous analytics. The amount of charts and graphs that it provides, it's pretty incredible. These are two of the interesting graphs that I picked up. The top one, you can see that between April 21 and May 2nd, there has been 38,221 requests, of which 13,945 errored out. So you can delve into details and see what the cause of the errors were. In this case, it turned out to be 401 and 400 errors. So 401 means that these were unauthorized. So this was the time we had just launched, so the developers didn't really know what is the right API key to use, so most of them were unauthorized. And 400 is because they didn't provide all the required parameters, so our server just rejected it. So we could delve into it and we could find out as to what the problem was. So this helped us take corrective action and reach out to these developers and tell them as to what is the mistake happening. Because without that, I mean, you'd be pretty much blind, right? You wouldn't know what these errors were, you have to look into the logs, and it's just a nightmare. Let's look at Apigee in action. Who's excited? I have to mirror this. One sec. Displays. All right. So once I log into the Apigee console, this is how the dashboard looks. So we can see at a glance, what does the traffic look like for this month? How many were errors? I could dig further into it and find out what these errors were. So how does it all begin? Let me click on the API menu item on the top and click on API proxies. So the first column here lists all the proxies that I have created. The second one specifies the environment that it is being deployed on. So you can see that there are two environments, test and prod. Test is the one that as developers we use to iterate around our development, and once we are really happy with it, we deploy it to production. And that is the secure environment. Let me take one example of Ticketfly API. So this is a proxy that is built with 3 resources. So each of these resources behind the scenes hits our server. In this case, it is ticketfly.com/API, and you can see that the version we have specified is v1. This tells that this is the first version of this API. Once we change it, the ordinal number obviously would increase. The column out here, method says as to what is the HTTP method, is put or get. And if I click on the develop menu item, you can see further details as to how this proxy was actually developed. We did it using multiple policies, which were all Apigee policies. But you could build something of your own as well. Like if you want to manipulate the request parameters that are coming in. Like in our case, we take the API key and we actually extract what is the org ID, what is the app. So that's how we get to know which user is authorized to use which API. But you get the point. So basically, you can manipulate the request parameters that are coming in. You want to add in some more information to the API. This is where you would do all that. And generally, when we create a new policy, we publish it so that the next proxy which is being developed can reuse it. So we follow a dry principle, like do not repeat yourself. And you can test it clicking on trace. So you can actually see as to what is the path that is being followed. Like for example, if I pick this URL and plug it in here, and I say start trace session, and I'm sending in a GET request, you can see that the response comes back with a 200. Okay, there's something wrong with the graphics, but generally it shows every step that the proxy actually went through, so it's very nice to debug. So if there is any problem, you can see what is the step that really errored out. Now I click on the Publish menu and select the Products menu item. So once the proxy is designed, you are happy with the abstraction layer that you built around your APIs, you go ahead and package them into products. Here's a big list of products that I was playing with. Let's take one example. So if you look at Ticketfly Ticket Exchange, this product has one proxy. It has only one proxy, but theoretically you could put in multiple proxies and package them into one product. And once that is done, Ticketfly is done with the Apigee configuration on our side. So as a Burning Man developer, I come in out here and I register myself with an app, with a product. So in this case, I have registered with 3 apps. And for every app that I register, I'll get myself a secure API key. So it's only with that API key that is mine, can I access the APIs that this product exposes. Apigee comes with like really cool analytics. It comes out of the box, which was a really plus point for us. Like for this case, say I click on analytics and I select endpoint performance. And you can see again the response time, what is the traffic, how many errors. payload size, a lot more. And if you have APIs that is going to be accessed across devices, like on your tablet, on your mobile, on your desktop, you could even see, you could pull in a report which talks about, which will give you that numbers as to how many users are accessing across your devices, what location, what time of the day, and so on. GeoMap talks more about location. You could delve into those details. Yeah, so in short, a whole lot of analytics. Sure.
So, is there like a role based control kind of concept?
Yes. Yes, yes. The question is, does Apigee provide role-based access? So can you assign some particular roles to a user and can you change it through the console? Yes. So it does provide. Yeah.
Do you have any kind of alerting notifications when you have thresholds being exceeded, like, a whole lot of access, unauthorized access requests could indicate someone was trying to get to your data inappropriately? Do you have anything that's doing that, or are you having to watch?
Sure. The question is, can you configure alerts so you can be notified instead of watching it? And the answer is, I don't know. So my guess is yes, we are not doing that. So in our case, we monitor it, as in we generally have a monitor on the floor, and then it displays these graphs. So someone keeps looking at it, and generally when there is an error, I mean, unless your server goes down, I mean, for those we have, on our application itself, we have alerts, but on the API side, as to say the performance is 30 milliseconds, and if anything goes above 60 milliseconds, you want to be alerted, that would be really cool to have, but we don't have that. And I'm not sure if Apple provides it, but I could look it up for you. Yeah. The documentation is pretty exhaustive, actually. So, if we go to the docs and search for alert, let me see if something comes up. Yeah, looks like it does. Yeah. So, well, the answer is yes. Cool. So, references and further reading. There are RFC 2616, RFC 3986. These are the specifications. There are really good books. Architectural styles and design of network-based software. There are also really good YouTube videos if you want to go learn about how Apigee uses or actually integrate any of these tools. I mean, Apigee is one example, but all of these tools work more or less similar. So if you want to integrate your APIs with any of these tools, there are really good YouTube videos as well. And behind the scene, we always follow the REST architecture pattern and HTTP protocol. And there are a bunch of good YouTube videos around that as well. Thank you. I want to thank Brightroll for hosting, and for all of you for your time, and my Ticketfly folks for all the support as well. I'll be around if there are more questions.
Yeah, questions now?
Yeah, sure.
So, I'm just curious, like, what are a couple of the biggest mistakes that you've made along the process that you would make the next time?
The question is, what are the mistakes that we made in this process, and what did we learn from it? Mistakes, we made quite a few. So, like I said, we learned the hard way, as in we have to paginate. We have to make sure that we really have that ability to throttle the users. When we started off, we exposed our APIs, and we don't have any monetization around these APIs. All our APIs are free, so anyone could hit it. And there were a lot of bots and a lot of faulty clients, which we had some malicious attacks as well, which tried to bring our servers down through the APIs, and we knew that we had to protect our servers against it. So that's when we started enforcing both pagination as well as limiting, being thrifty actually from the amount of data that we transfer from the server to the client, be really thrifty about it. Yeah. Sure.
What kind of resources do you have on the project? Do you need like developers or BAs or who are the type of people working on it?
Sure. The question is, what are the developers working on this project? Do we need business analysts, product managers, marketing people, engineers? And answer is all of them. Yeah. So when it comes to the designing of APIs, we really need the whole group to come together to design it, because it has a little bit of everything, right? I mean, as engineers, you can design the APIs, but then as a product manager and as a business analyst, you have to see who is really consuming this API and what is the requirement coming in from their side. Because when you sign in the contract, you go into details specifying how many requests per user per month, and these numbers you cannot really come up by just looking at your application size. I mean, theoretically you can always deploy onto more and more servers, and you don't want to prepare for something that you're not really expecting. So it's a little bit of all of them. Sure.
Did you guys investigate the overhead that these different API sort of proxy layers introduce?
The question is there an overhead, and did we investigate if there is one? And the answer is no, there is no overhead. It in fact protects us and it provides us a lot of features. So if not using one of these tools, you have to definitely build something in-house. So we cannot really expose the APIs as is to public anyways. So whether you're doing it in-house or using one of these tools, which way to go, it depends on the cost, it depends on the time that you have. But no, the overhead, if anything, would be similar.
About time, how long did it take from when you signed the contract to when you actually delivered it?
3 months. How long did it take for the whole project between when we signed the contract and when we delivered this project? Yeah, that's a question.
Yeah, right now, let's say there's a bootstrap company and they don't really have funding and the website didn't really show how much it is. Do you think it would be okay when you're starting out to just get the developer thing and use the API keys for that?
Yeah, the question is, if you're bootstrapped and you don't really have funding, can you still use one of these tools when you don't know the pricing information?
Because I noticed they have the free developer version. Do you think that's good enough when you're starting out?
Yes. So, like I said, even in our case, Burning Man is a big client, and they are our only client consuming these APIs for now, and we are still on the free account. We haven't upgraded to the enterprise version. It's actually very expensive. It costs as much as one developer per year, which is very steep for a tool. Yeah. Sure.
So you don't need to deploy any client on your side, or?
So with the question is, did you have to deploy any client on your side to use this tool? So most of these tools come with both the options. So Apigee case, you could deploy it on your own server, you could deploy it in-house, or you could deploy it on the cloud, which was again one of the really cool things that we liked about this tool, because we wanted that flexibility. We have our own data center as well as we use AWS. So we wanted that flexibility to have deployment either ways. And so for now, it's on the cloud for us, but we could any day switch to our data center. Sure.
Do you use Apigee as a gateway for your web service?
So the question is, do we also need an external load balancer in addition to using Apigee as a proxy? Yes. So the answer is yes, because your APIs are protected by the proxy, and you could configure the load balance at that point. But then eventually when it hits the application, your applications also should be able to scale. So you need a load balancer at that end.
Why did you use Apigee over the other tools?
So for us it worked out. As in this use case that we were looking at, it worked out because we were looking at ease of setup, and cost for all of them was comparable. most of them provided also the other set of requirements like security, throttling, or even monitoring of metrics. Even all of those were common. For us, it was not contacting any salespeople. I could just download it and build a prototype, and then it just satisfied our needs well, and we decided to go that route. Cool. Any more questions?
One more question regarding security. So you mentioned that security is handled by the Apigee layer. So between the Apigee layer and your API, that route is still open. So how do you manage that?
The question is, Apigee provides security between the proxy and our API. What about the security after that?
That part security. Apigee and the client.
Apigee and our API.
And the end client.
Which is our API.
No,
okay,
that's the developer. Yeah.
Okay.
So, but the security is because we are using that proxy. Now, if somebody want to use our API directly without going through that proxy, our API is still open. So, how did you close that loop?
Okay. So the question is, what happens if someone hits our API directly? How do you manage the security at that layer? So in our case, we have locked down our APIs. So no one can hit our APIs directly unless they come through Apigee layer. So for us, that is the case. But then you definitely need some kind of OAuth mechanism eventually. I mean, you'll have some LDAP server or somewhere where you keep your users, and you have to integrate that. In our case, I mean, it was a simpler use case. So we locked it down, and anyone who needed access to these set of APIs, because it was so designed for Burning Man, so there is no reason, at least as of now, unless Ticketfly designs secondary ticketing, and we decided to bite into StubHub's market or eBay's market, unless the business plan changes like that. For now, it's solely for Burning Man, so we have locked it down. Cool. Yeah.
For Apigee, when would you have to pay to them?
So it depends on, they have various pricing models. So the question is, what is the pricing model for Apigee? So long as our APIs are free, that is, we don't have monetization around it, it's free for us. But then eventually when you want to, and even today, right, we use just the console to configure. I showed you how we configure the proxies, the products. It's all done through the console, but everything could be done through the code itself. And that would be the way to go if you have like thousands of APIs and you're trying to use Apigee over it. So for many of those use cases, you might have to go through the enterprise model. For our use case, so long as we are restricting it just to Burning Man, I think we can be free forever. Yes?
So you mentioned, you answered this question about locking down. I was just curious how you did it.
There are various ways to do it. I mean, you could do it at the server level, you could do it at the load balancer level. It's more systems. You can lock it down. There are the mechanisms. So we did it in our load balancer. We use F5, and you can say as to what are the clients who can access it and whom you want to block and stuff. Awesome. One more?
You said you went with Apigee because you're still in that, but where was that decision made in training people?
In this case, it was all on the development side. But then we can think about long term, like if we really want to go have many more APIs exposed, and we really want to go all of them, we want to route them through Apigee. In that case, we might have to reconsider, because right now we don't really have any monetization around our APIs. No, we didn't have to. I mean, I can imagine if there are other clients, they might want to get involved. Our clients weren't that technical, so they didn't really, they so long as they could access it and they knew how to, they were good. Awesome. They were all great questions. Thank you, guys. I'll still be around, so if you have any more questions that you want to talk about or discuss more, or if you think there could be more cooler tool that we should explore, I'll be happy to hear. Thank you.
To tell our life Millions of hearts have been broken just because